Hello. Our next topic to discuss, topic 7, will be arrays. An array is essentially a way that we can store multiple pieces of information, such as multiple pieces of data, in one large connected structure, rather than having to make a separate variable for every piece of data. Arrays allow us to join multiple variables of the same type together and index them in a way, and by that I mean number them in a way that we can access them in a easy to understand and sequential type of manner. So we're able to keep similar types of data together, just like when you go on Brightspace and go to your grades, you have a grade for each assignment all stored in one place. An array of grades, for example, would be all of those grades, one in each row or one in each column. Excel is a common tool for creating arrays with multiple dimensions. You have the X and the Y dimensions, right? So we're going to look at how arrays are structured in C programming and how we can use them and integrate them with our other processes we've learned so far. So let's start with a general introduction to arrays. An array is just a collection of data, like we already said. It could be a list of names, a list of temperatures, or grades on exams. It could be run times in a track and field event for different lengths of running distance. We'll see that example later in our lab is why it comes to mind. But it's just a collection of similar data points. And why do we need arrays? It allows us to work with much larger pieces of information. So thus far, we always have the user type in their information using cin. We just more recently started using files. So you could have a file with a number of data points. But if you had, let's say, 1,000 data points in a file, a text file, it's easy to read those in, but you would need 1,000 variables in what we've been doing so far. With arrays, we can make one name that can hold 1,000 data points within it to help organize our code and give us easier access. So if you look at these two examples here, a single variable holds one piece of information, whereas an array, single variable here, whereas an array can hold many pieces of information. So, and it is indexed starting at 0 and then counting up. So in this case, there are 5 elements, but they go 0, 1, 2, 3, 4. And these values are what are in each element. And we can set up the array to be whatever size we want. So this is a very convenient and useful way of looking at multiple pieces of information. So to create an array of size 5, for example, we create arrays just like we create variables. We have to give them a type, and then we have to give them a name. The difference when working with variables is we now also have to give it a size. So that's what this 5 in the square brackets represents in this declaration here. Essentially, it creates 5 separate variables, and they're all under the same name, just with a different index. The index is the number of the element in your array. So saying int score 5 is like saying you create score 0, score 1, score 2, score 3, score 4. And so that's 5 total, 0 through 4, or 5 total. Visually, you can picture it like this number line here. Remember that your numbering starts at 0, and you access it just with the square brackets. So if you were trying to get this information in index 0, then you just use this score square bracket 0 to access that, and so forth. So you just write the index that you want next to the name in square brackets, and that accesses the piece of information in that particular element at that index. So keep in mind these different terms. The index goes from 0 to your maximum number. The array length is the total number of elements, and usually it would be the highest index plus 1. So this is 10 elements. The indices are 0 to 9. Each of these blocks that can store a piece of data are called an element. That is visually what we're working for. And you create them just like you create a variable. It needs a type, and every element will have the same type. It needs a name, and then it needs a size. So the variables making up the array are elements. We already mentioned that. And each element has an index starting at 0. This is very important. If you start at 1, you will miss part 1 of your data points. And so the largest index is the size of the array minus 1. So just keep that in mind as we are looping and moving around in our arrays. And so the variables in an array can have any of our standard types: int, double, float, char, so forth. And all of the elements, all of the indexed variables have that same type. It's known as the base type of the array. So if you know one of your numbers is going to be a double, you need to make the entire array of doubles. And you can use an indexed variable anywhere that you would use a regular variable. So if you created this array called score with 5 elements, they would all have the type integer. And then to use them like a variable, you just put the number of the index. So if you wanted to use score like a variable and you want the information at index number 3 or element under index 3, that's how you access that. The value, instead of just a 3, you can have something else in there, such as x plus 1, or have an I. If you're going through a loop and counting up, you can put that counting variable in that index. And that's a way to move through an array as we loop by counting, which is a very common technique, and we'll cover that example in the lab. But, so you can do things like this. So if your n is equal to 2, score of n plus 1 equals 99, assigns the value, we assign values just like we do with regular variables, into this position, and we have n plus 2, or sorry, n plus 1, which is 2 plus 1, or 3. So score element at index number 3 would be equal to 99 using this code that we have here. And so by making the index variable, it's how we access a lot of our statistical functions, such as adding an entire array together and creating averages, finding minimums, maximums, standard deviations, things like that. So here's an example of moving through a loop and getting information on each element. So for I going from 0 to 5, incrementing by 1 each time. So 0 to 5 means you go 0, 1, 2, 3, 4, which are the index of score that we created earlier. And this code is just doing a cout of the element, and it's saying it's off by the maximum score minus the score in the element we're at. So this will tell you how much is each score in this particular case, how much is each element off from the maximum that it could be. And it reports this for every element of your array because you loop through it. So again, looping through elements one by one is how we access a lot of our statistical functions. In Excel, you may highlight a whole column and click the little button that says average. We can do that, but we have to do it in a more simplistic way because we can't just gather the entire array at once. We have to add them into some storage variable one at a time and then divide by the total number to take an average, for example. So we have to break down our functions into things we can do by stepping through a sequence or stepping through an array using loops, because loops are one of our main kind of working functions that we use. So talking about functions is in the C style function, not just as something that we use like a loop. When talking about actual functions, you can use arrays with functions and send them as a normal argument. If you leave the square brackets blank, that means it sends the entire array, not just one element. So this is very useful for just keeping your code organized. So you can send arrays to functions to have something happen, no problem. So when working with multi-dimensional arrays, we've been discussing just 1D arrays so far. So you envision a single row of elements and a single row of indices. When you start talking about more dimensions, you now need to indicate which dimension you're talking about, or which point specifically, and it's addressed by those dimensions. So for example, in a 2D array, you have a row and a column. And so you'll have 2 index numbers associated with a row and a column. So for example, if you have characters, that's a 30 by 100 array defined in this way, that creates an array that has 2 index values. The first, you could think of that as the rows. It would have 30 rows in this array, and it would have 100 columns, or each row would have 100 characters. So this would look probably similar to a 30-line text document. But you can declare arrays with multiple dimensions using this format. So each index is enclosed in its own brackets when you're creating this. So this would be an array called page. All of the elements are of a type character, and the index are 30 in the rows and up to 99 in the columns, so 0 to 99 or 100 total. And to access those, you have to just indicate each array. So if you wanted this element in row 0, column 1, you would just say A, square bracket 0, square bracket 1. And you could use that like a variable. So if you have multi-dimensional arrays, and we will have some activities in our lab that look at this, this is how you use them, just by indicating all required indices. So just some more examples of stepping through that, one index or the other. If you add to the row, you're moving down in the rows visually. If you add to the column, you're moving left or right in the columns visually. So you could have a lot of different information stored for a lot of different reasons, then access any of it just by pointing to the correct index. One thing that you'll frequently see is we like to scan all the information with our computer program, or C program that we write. And so you can count through, use nested loops to do that. So have a for loop counting through the rows, and then inside that for loop, so for every row, count through every column. So just kind of visualize nested looping. So for row 1, count through every column. For row 2, count through every column. For row 3, count through every column. Maybe you're trying to find the sum of this entire array. So we need to think about arrays in a way that makes sense using loops. For me, that's visually. And so I am able to keep better track of where I am if I think of arrays visually. You may have other techniques that work for you. But a one-dimensional array is typically viewed as a line, or known as a vector. A two-dimensional array is known as a matrix. A three-dimensional array, you can still visualize because we have 3 dimensions available. So you have the x, y, and then z being a depth in there. For a more array, they get harder and harder to visualize. You can have your own tricks for making sense of that. A 4th dimension, for example, might be time. If you think about medical imaging, MRI imaging, you have a 3D picture, but it's over time, so you have a 4th dimension. So think about if you have a way of visualization that works for you for more than 3 dimensions. It's just an interesting thought exercise. For me, I think about Rubik's Cubes hanging on a keychain, and you're moving through 3D Rubik's Cubes one at a time over time, and that key ring that it's on, the Rubik's Cubes are hanging from, is your time dimension. It's a little abstract, makes a lot of sense in my head, so should you ever work with time-varying 3D quantities, you may have to become more familiar with working with these as well. But we can make as many dimensions as we want with our arrays. Usually the lower dimensions make more sense in terms of our applications. And the applications of arrays are many. We're going to see a lot of those in our lab. We'll see collections of data for running a track and field event where there were a number of different distances run, and for each distance you have 5 top scores at that distance. So we're using a 2D array. So in the lab we'll look at 1D arrays, we'll look at 2D arrays, and then we will look at a 2D array application related to images. Computer images are always made up of pixels, or well, usually made up of pixels aside from some certain formats. And each of these pixels, when combined together, maybe 1000 by 1000 pixels, now looks like an image because you have some color value in each pixel. Every pixel has a row and a column, and you can easily move through, modify, and work with images just by understanding how to work with arrays and loop around through them. So that's what our lab problem will be dealing with after we do some examples of 1D and 2D arrays. And then next time on our final topic, we'll be talking about characters and strings. So this builds on arrays because if you have an array of characters, you now can write words, you can write sentences. And so in the movement towards translation into human-like communication, characters and strings give our applications a lot more life because now we can create and store and work with text that we can read. So let's move on to our next lab, and then after that we'll wrap up with our last topic. So I will see you there.